Thank you very much. We've heard a lot about commerce and changes in the Arctic. And what I'd like to tell you a bit about now is the science in the Arctic and some of the changes that are going on. So I'm going to tell you about scientific research in the UK, but all my scientific colleagues in the audience will know very well that nobody does science alone in the Arctic. It's a large place, it's remote, it's quite difficult to work in. There are some very big science questions, and I think most scientists in the Arctic work in multinational teams with intense collaboration, regardless of politics. Hooray. And so I'm going to tell you a little bit about some of those projects. To start off, I'm going to show you this, just a few general slides about Arctic climate change, just to set the scene before I talk about the UK projects. And I'm sure that you'll have seen many of these diagrams with the red areas. These are always quoted by the media. And you can see the red areas show where the temperatures have changed the most over the last 10 or 20 years. You can see there's the Antarctic Peninsula there, but over the Arctic there's that really big red zone. And I'm going to come back to that in a moment. Now, you all know that the sea ice has been decreasing, that the areal extent of the sea ice has been decreasing, but I think more importantly than that, what is happening to the sea ice is that it's thinning. So in the past, there used to be ice that was quite thick, called multi-year ice, that had formed year after year after year through cold winters. And what's happening now is the thickness of that ice is decreasing. And most of the ice in the Arctic now, in the Arctic Ocean, is actually single-year ice. First-year ice. So it's very thin and it's very susceptible to melting. And I think that's what we've got to watch. That's what the weakness now in the Arctic sea ice. Also, the other thing that's happening in polar seas, both the Arctic and the Antarctic, is that the oceans are becoming more acid. As the excess CO2 is being dissolved in ocean waters, it's forming an acid, and it's beginning to etch away at some of the carbonate shells of some of these animals. So you can see here this lovely little thing, which is only less than a millimetre in diameter, called a pteropod, which is actually at the base of the food chain for many of the marine animals in the Arctic. And they have a tiny shell inside, as you can see there, and that's beginning to be corroded by the acid in the ocean. And so if we start affecting the food chain by acidic oceans, then we're in for real trouble with the rest of the larger animals. On land, the Arctic tundra is greening. We've seen plant zones move further north, and we've also seen some of the permafrost under the Arctic tundra beginning to melt. So we know all these things are happening, but why they're happening and understanding why they're happening and the details of what's happening is what scientists are really interested in now. And I'm going back to these zones here with all these red zones. So there are diagrams here which are generated by numerical computer models. And these are the ones used in the press, and you can see the red zones in the Arctic showing that there's warming. But these plots are used for predictions for the future as well as telling us what's happening. And you can see the red zones are beautifully sort of smoothed out across the Earth. There's beautiful zones of climate change. And the question is, how are these models generated? And if I show you where the data points are, if you keep a look at the Arctic, they're the three different computer models. Look at the Arctic. And what this plot shows is where the actual data points are, where scientists have gone into the ground and measured information from the field to verify those climate models. And you can see at both poles, there's a very lonely dot up there in the Arctic as a data source. And what actually happens is the computer modelers extend their mathematical equations into the Arctic, into the Antarctic, and make it look as if there's a huge amount of data there. But the real story is there's a real paucity of data in the Arctic regions. And if we really want to understand what is happening now in the Arctic and understand why it's happening and what will happen in future, we really need to get into the Arctic and do some science in the field and really get our feet dirty. In the UK, the Natural Environment Research Council, our main body of funding, has launched a large research project called the Newark Arctic Research Programme. They dedicated £15 million of funding to this research programme 2 or 3 years ago, and there have been many projects as part of this programme working all over the Arctic in collaboration with many Arctic continents and Arctic scientists. It comes to a close in a couple of years' time, and then we really need to think about what comes next. I'm just going to show you just a real glimpse of a few of those projects. There are about 10, 12, 13 projects and some side projects from this. They've mostly done 2 years of work now, and the results are just about coming through. So this one here is this fantastic picture of a ship going through the sea ice. This is a Swedish icebreaker, Odin, that hosted the UK team, which you can see consisted of university people from scientists from Sweden and also from the States. And what the whole programme is trying to understand the complexity of the Arctic ecosystem. So it's not just about the ice, it's not just about the sea ice, it's not just about the tundra. They're all intimately connected. Somebody described the Arctic system to me recently as a biscuit tin. And you can imagine lots of things going on in the atmosphere that go into the tin in which the sea ice forms a lid. And then a lot of things go on in the biscuit tin in the ocean. And at the bottom of the biscuit tin where the crumbs are, there's all sorts going on in the ocean floor. And then there's holes in the biscuit tin at the side, which are the ocean gateways to the rest of the ocean. And so what goes in and what comes out is really important, and understanding how they interact is really key. So this project here was looking at clouds. If there's one thing we don't know about in climate models, and particularly for the Arctic, is about clouds and how they actually affect the climate and how they interact with the sea ice. So what this ship was doing with a group of UK scientists were trying to understand some of the impacts of the sea ice, the interaction of the sea ice with the open water, with clouds, and how the particles then rose into the air, and how clouds were formed. They generated huge amounts of data, so all the time these projects were trying to fill in those gaps in the Arctic data system. And you can see they're also looking at methane and how that affects the global atmosphere across the Arctic Ocean. Another one, a really important one, is how the atmosphere and the sea ice and the ocean interact. And we all know that what's happening, we've seen what's happening, that some of the melting sea ice, what's happening to the ocean currents underneath that sea ice, is affecting our climate in the UK and in Europe generally. And we've seen, in the last year, we've seen some of those big pressure cells just stalling and sitting over, they've certainly sat over the UK and given us terrible periods of floods. And they haven't moved on. Usually our weather in the UK moves on pretty fast. And they've been stalling and stagnant over the UK. And scientists are beginning to think this is related quite clearly to what's happening in the Arctic and the impact of what's happening to ocean circulation related to what's happening to sea ice in the Arctic. Also, the other thing that's become out really important from some of these projects is the seasonality of the Arctic environment and the Antarctic, but the Arctic. So everything changes from winter to summer. There's an extreme change in the state of the ocean and the state of the atmosphere. So just going up to do a summer cruise is not good enough. What we really need to do is study the oceans and the atmosphere all year round in the Arctic. The other thing which they found, the ships went out into the Arctic Ocean just off Svalbard, and they used geophysical equipment to do seismic profiles through the seabed. And what they found is, you can see there's a diagram here, and those spikes that are coming up, the seafloor is the red zone, and the spikes that are coming up are methane bubbles coming up off the sea floor. So methane is buried as frozen nodules on the sea floor in many world's oceans, but a lot around the Arctic. And as the ocean waters are beginning to warm up, that methane is melting, the frozen methane is melting, and it's beginning to seep up through the seawater. At present, though, we know that this methane is staying within the ocean water. We've had another project has had a research plane flying around above the ocean, trying to measure the methane that is coming off the ocean, and they've not yet detected this methane escaping from the ocean floor into the ocean and into the atmosphere. So far, it's staying in the ocean. But at some point, surely, the oceans will warm enough to melt more frozen methane, and then we may see some of this methane coming up and into the atmosphere. We've also got scientists working on land, and so you can see some hardy biologists here being eaten alive by mosquitoes, no doubt. And they are looking at the shrublands to understand the carbon cycle. What happens when all that tundra begins to melt, the permafrost melts, and all the methane and all the carbon starts coming out of the tundra? And you can see they're looking at how there is a flow of carbon from the tundra, from the permafrost, into the rivers, into lakes, and into the atmosphere. And what they've been finding is that as the climate is warming, there are more plants that are growing over the tundra as it's beginning to melt. And that's a really important change in the way that the tundra is cycling carbon and adding to warming in the atmosphere. And finally, just an interesting one is that the Royal Navy have been contributing to UK research in that years and years ago they they probably still do now, collect a lot of data in the Arctic Ocean when it was ice covered and in ice-free parts of the ocean. And all that data has been extremely valuable. So now time's gone and that data has been declassified. The scientists have been able to use that data to look at turbulence in the ocean, which is really important to understand in relation to the sea ice and to ocean currents in the Arctic Ocean. And they've been able to find interesting stories about how the energy regimes in the ocean, how the turbulence is very different underneath the sea ice compared to the open ocean. And that's a lesson we need to take into account when we think about what we're going to do in the ocean in the future. So finally, just to summarize that, all of those research projects and more that have been going on in the UK science and in other international science are really now beginning to highlight some of the very fine details of changes in the Arctic systems, not just the sea ice, it's everywhere, there are changes everywhere. But we really do need to get into the field, we need to collect more data. We need to do it because we want to understand how the Arctic is changing and why it is changing, and then we can work out what's happening in the future. But we also need, the climate modelers need that information from us to check their models, and they're the people who are going to predict changes in the future that shipping firms are going to use, that the mining firms are going to use, exploration are going to use those models to try and understand future predictions. I put up there about seasonality. The polar regions are the places on Earth where the climate changed most drastically and first because they're at the most sensitive ends of the Earth. And the seasonal aspects of those climates, particularly in the Arctic, are what is really driving some of the complexities of the systems. And it's not really good enough just to go out in the summer when the weather's quite nice and when you can go to ice-free areas and study some of the science there. That's important. But what's really important is we understand what happens all year round. So we go out in winter as well. And so we really need some really inspirational, innovative sort of expeditions in which there have been some in which research ships have been frozen into the Arctic Ocean so that we can take measurements all year round. And this is really important, I think, to try and understand the whole cycle. And we need to monitor for long term. A lot of what we do in the Arctic, every nation, is quite short term. We have short-term grants and we go there just for, say, 3 years or just for a couple of field seasons, and we can tell you what's happening in a couple of years. But the climate in the Arctic is very variable, and we need to understand how that variation pans out in the longer term. And I think my last point is that industry and science must work together. Industry can also benefit hugely from what the scientists find, and they need to understand, whether an operation could be formed in the winter more safely or in the summer more safely. But also industry and anybody in the Arctic can help collect all that data to fill that data gap that we have. So I think the Arctic is a really perfect place for industry and science to work together in harmony for the good of the Arctic in the future. Thank you.